Hey guys, I'm going to show you a polynomial long division hack, all right? A little shortcut kind of way where when normally we would be doing polynomial long division because of the way our divisor looks, we can actually use synthetic division if we're careful and follow a couple of extra steps, all right? So take a look at this problem. We have 3k cubed minus k squared minus 7 divided by 3k minus 1. Now, normally we can only use synthetic for a linear binomial, meaning 1x to the first power and then plus or minus something. So I'll just put x plus a. Usually if it's 1x plus or minus something, that's when we use synthetic. Because we set our divisor equal to 0, we change the sign of this value to solve. So normally synthetic would not be an option for this problem. But here's the hack. Here's what you can do. Because we need this to be 1k and not 3k, we can divide by that 3. All right? So if I divide both of these terms by 3, forgive my crazy mouth here. All right. Then this would cancel out and be 1k like I want. So it's k minus 1/3. Well, if I do with that what I normally do, right, where I would set this equal to 0 and solve, then my k that I would use as my divisor outside the box is going to be positive 1/3. So here's the biggest difference. We're going to have to work with a fraction. Okay, so I'm going to use 1/3 as my little divisor here outside of my synthetic division box. So I still draw the box. I'm still going to use my coefficients from my dividend, my first polynomial here. So 3k to the third minus 1k squared, so negative 1. It is missing the k term, right? The exponent should go 3, 2, 1, 0. So since I'm missing that term, remember I use a 0 in its place. And then the negative 7. All right. From here, I'm going to do the process of synthetic division the same way I always would. So I would bring down my 3 here. And then, whoops, I would multiply. Sorry about that. So I'm going to multiply the same way I normally would with, well, it's getting rid of everything except what I need it to. All right. Oh, okay, there we go. All right, so I brought down my 3, and then I'm going to multiply it by my 1/3. Okay, so 1/3 times 3 is just 1. All right, and that's the thing. You might think, oh no, I've got to use a fraction. But most of the time you're going to find with these problems that you're going to get something down here to multiply your fraction with that's a multiple of your denominator. So you're still going to get a whole number. So 1/3 times 3 is just 1. All right, and then negative 1 plus 1 is 0. All right, what's 1/3 times 0? 0. All right, that's an easy one. 0 plus 0 is 0. All right, what is, let's see, what is 1/3 times 0? 0 again. So then I get negative 7. This is an interesting one. It didn't have a whole lot to it. Okay, so here's the other part of the hack, quote unquote. So, right, this was the first part here where we had to divide by that coefficient of k in this case in order to make it fit a linear binomial with a coefficient of 1. So here's the thing. We also have to divide these coefficients here by the same coefficient we did up here. So because I divided this by 3 to get rid of the 3, I have to divide this by 3 and this. Now these are zeros, so nothing's going to change, but if this was any other number, it would actually divide by 3 and give us a new value, okay? The one thing I can leave alone is the remainder, okay? We can leave the remainder as negative 7. We don't need to change anything, all right? So now if I were to rewrite this, again, the degree of the dividend was cubic, so we go down 1, so it would be 3k squared. All right, and then because the next terms are just 0, it'd be plus 0k, which I don't write, plus 0, which I don't write. And then I would just do my remainder, so plus negative 7 over my divisor, 3k minus 1. My mouse doesn't like the bottom of the screen, sorry. And there we go. Now, if we did the same problem with long division, we would get the same answer. All right, so this is just a cool little hack for how to do this. I'm going to show you one more. All right, here we've got one with a little bit higher degree. Okay, we have 4r to the fourth plus 29r cubed minus 24r squared plus 8r plus 5. So notice our exponents go 4, 3, 2, 1, 0. So we aren't missing any terms. All right, but we do have a 4 in front of the r. And I'm actually just going to use x instead of r, just because I prefer the way x looks. So I'm going to divide by this 4, again, because I need the coefficient to be 1, not 4. So if I did r plus 1/4 equals 0, it's going to be r equals negative 1/4. So I changed the sign of the fraction just like I would if it were a whole number. All right, so then I'm going to set up my synthetic. So put my negative 1/4 outside. My box. Write down my coefficients. 4, 29, negative 25. All right, stop that. Plus 8, and then 5. I didn't need to put the plus. I don't know why I did, but it's a positive 8. Bring down my first term like I always do, and then multiply, again, the same way we normally do, but we're using a fraction. So negative 1/4 times 4 would be negative 1. 29 plus negative 1, 29 minus 1 would be 28. Okay, and see what I mean here? 28 is divisible by 4. So you can also just use your calculator if you have trouble multiplying with the fractions. But here, 1 times 28, it'd be negative 28 divided by 4, which would be negative 7. All right, there we go. Add these. Negative 25 plus negative 7 is negative 32. Also divisible by 4, right? Negative 1 times negative 32 would be positive 32 divided by 4, positive 8. 8 plus 8 is 16. All right, multiply. Negative 1 times 16 is negative 16. Over 4 would be negative 4. And then 5 plus negative 4 is 1. All right. So remember, we had to divide by 4 here to get it to fit the right model. So I have to divide these by 4 as well. Okay, so my new coefficients are going to be 1, 7, negative 8, 4. My remainder, remember, stays like it is. I don't have to do anything to that 1. So now I just have to write in my variables, and since we started with r to the fourth, we go down to r to the third. All right, so it'd be 1r to the third, or just r to the third, plus 7r squared, minus 8r, plus 4, and then we do our remainder, plus 1 over 4r plus 1. So there you go. There's your synthetic division hack for long division problems.